Let's talk about solutions to a inequality in x and y. So it has got two variables, and in two variables we call that. So here's our inequality. This inequality has an infinite number of solutions. In fact, even if it wasn't an inequality, even if it was an equality or an equation, it has an infinite number of solutions, because I can keep plugging in values for x and y that make the equation true. I could change this to an inequality, and I can plug in values for x and y that make this inequality true. It's a lot easier to find solutions for this inequality than it is for an equation, because for an equation, only the points that are on the actual line, this is some sort of parabola, and only the points that are on the line are solutions to that equality. If this said equals, if this had said equal, only the points that are actually touching the line would be solutions to that inequality, or to that equation. But when I make an inequality, I basically make this, all those points on the line now are not solutions. That's why it's got to be a dotted line, and either everything above it is a solution or everything below it is a solution. So we're going to talk about how you know and how you do all that. Alright, so let's first of all graph this equation. Graph this inequality. I actually don't have to graph it. If I want to just find out if these are solutions or not, all I really have to do is plug that in for x and that in for y and find out if it's true or not. So let's plug in 2 for x and 1 for y, and what would we get? We get 1, because that's y, is greater than 2 squared plus 4 times 2 minus 5. Now I'm going to put a little question mark above there. Is that true? Is 1 greater than that big mess? Let's find out. 1 is greater than, let's simplify this with the order of operations. 4 plus 8 minus 5. What's 4 plus 8? 12. What's 12 minus 5? 7. Is this true? 1 is greater than 7? Is that true? No, it's not. So this is not a solution. Okay, let's try the next one. -1 for x, 10 for y. So I'm going to plug 10 in for y. I'm going to say greater than and put a question mark by it. Now be careful, put a parentheses around it, because it's a negative and you're squaring a negative, plus 4 times -1 minus 5. Let's again do the order of operations. Is 10 greater than 1 minus 4 minus 5? 1 minus 4 is -3. -3 minus 5 is -8. Is 10 greater than -8? Is that a true statement? Yes, it is. So that is a solution. -1 comma 10 is a solution. And then let's do this last one here. 0, -5. I'll do that over here. Right, so if I plug in 0 for x, 0 for x, and -5 for y, I would have -5, again I'm plugging that in for y, is greater than, I'm asking myself, is this greater than 0 squared plus 4 times 0 minus 5? Well, what does this simplify to? 0 plus 0 minus 5 is just -5. Is this true? Is -5 greater than -5? No, it's not true. It's equal to it, but it's not greater than. If this had said equal to underneath here, which it doesn't, but if it had said that, then I would say yes, that would be a solution, but it doesn't, so I say not a solution. Alright, so now let's talk about another way to visualize this and to understand kind of how solutions are related to graphs and equations and all that kind of stuff. So first of all, we're gonna now take this to the next step, and we're gonna graph this red inequality, We're gonna graph that, and we're gonna graph it by finding the vertex. Remember, this is a quadratic equation because it's being squared. The vertex is going to be -b, which is right there, the 4, over 2a, which is, you can't see it, but there's a 1 in front of there. So it's 4 over 2, which is just negative 2. Now that's only half of your vertex. That's your x-coordinate. Now our y-coordinate, we're going to find, I should have done all this in orange. Our y-coordinate we're going to find by plugging negative 2 in for all the x's. And we're going to solve the equation. Let me make some room here. We're going to solve. Now you might wonder why I'm turning this into an equation now. Well, because I'm not really concerned with, I'm concerned right now with the line. I want to find out what the line looks like. It's like the borderline for that relationship between x and y. So I'm going to plug in negative 2 for x. Here I've plugged in negative 2 everywhere I saw x up here. I plugged in negative 2. And I'm going to simplify it. Be careful with this. That's going to be 4 minus 8 minus 5. So that equals 4 minus 8 is negative 4 minus 5 is negative 9. So my vertex is negative 2, negative 9. Alright. So negative 2, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is right there. That's my vertex. And you can see that it's a positive leading coefficient, or sometimes we call that a, because usually our standard form is ax squared plus bx plus c. Our leading coefficient is positive, which means it's opening up. In fact, I'll even show you the quick way to graph this. This 1 right here, a is kind of like your slope, but it's not really a slope because this isn't a line, but it's like your slope. If I go over 1, I'm going to go up 1. If I go over to the left 1, I'm also going to go up 1 because it's being squared. If I go over 2, 1, 2, I'm going to go up 4 because 2 squared is 4. It's a quadratic. There's something being squared here. So I go over 2, so now I'm here at the y-axis. I go up 4 because that's 2 squared. 1, 2, 3, 4. So there's that point right there. And we can check it. 0, negative 5, and sure enough, 0, 0, negative 5 should be on my graph there. And then I symmetrically can do the same thing on this side, because remember, this is a the line of symmetry is the line that goes right down through the vertical line that goes right through the x-axis. I'll draw it in like this. I'll draw it in kind of light. There is your axis of symmetry right there. If I go over 3, 1, 2, 3, I'm going over 3 on the x-axis, left or right, 1, 2, 3. If I go over 3, I wouldn't go up 3, because it's not linear, it's quadratic. I would go up 3 squared, which is 9. Make sense? So I would go up to here, and then symmetrically I would go up to there. Alright, so this now I can draw in my graph. And notice that my graph is going to be, I'll go ahead and just draw it in solid. It's easier to draw it in solid and then to erase pieces. There's my graph. I put the arrows on the end of it. And now I'm going to make a dotted line, which represents that my solutions are not on the line. The points on the line, like for instance 0, negative 5, that point right here is on the line. But this is not saying y is greater than or equal to x squared, blah, blah, blah. This is saying y is only greater than it. So which values are greater than that dotted line? All the values on the inside are greater. So now let's look at how these points over here would have made sense. Where was 2, 1 at? 2, 1 is 2, 1. Oh, look, it's so close to being inside my shaded area, but it's not. That's why it's not a solution. Negative 1, 10. Negative 1, 10 is way up here somewhere. That's inside my shaded region, so it is a solution. In fact, negative 1, a million is inside of it too, because these lines just go up forever. And so if you look at the picture, you can then see very quickly that point right there. I think that's probably 6, 0. 1, 2, 3, 4, 5. 6, 0 is not a solution. Why do I know it's not a solution? Because it's not being shaded. And this picture that I drew here represents all of the solutions to that original equation that I had up there. Y is greater than x squared plus 4x minus 5. So that's what solutions to equations are, and how you can plug them in to find them, and how a picture shows you all of the solutions in one quick little setting. That's why they say a picture is worth an infinite number of words.